All right, folks, Mr. Bucko back with some solving absolute value equations. We're going to do it graphically, and then we'll do it algebraically. We'll find that the algebraic method is a lot more efficient and effective, and probably more fun too. So we'll start with, I got all the information here, so I'll just kind of walk through this one step at a time. So to solve an absolute value equation graphically, what you can do is take this single equation and separate it into two equations on like each side. And then we'll graph those two equations and find out where they intersect. So we can essentially take, if we're going to solve 2 times the absolute value of x minus 5 minus 4 equals 2, we're essentially going to take this function here, we'll call it f of x. So this function, 2 times the absolute value of x minus 5 minus 4, and then 2. So g of x equals 2, or y equals 2, or however you want to interpret that. Then these are what they look like on the graph, and we know that. We can find that by plugging in points, kind of like we did with just graphing absolute value equations in general. Now they intersect at 2, 2, and 8, 2, as we can see on the graph. So the solution to this would be 2 and 8, because the y values are 2, which is what we have here. So 2 and 8 would go in for x to make this equal to 2. So the intersection is where the solution is. So it's a stop and think here. What does a graph look like if an absolute value equation has no solutions? Could it have only one solution? And how and what would that look like? And kind of one of those things. And we'll move on and see what those things look like. So we'll solve this graphically. So negative 3 times the absolute value of x minus 1 plus 5 equals 5. Solve it graphically. So we break them into the two equations we have. Negative 3 times the absolute value of x minus 1 plus 5. We can plot points, make a table. We can see what the vertex is. The vertex is 1, 5, because it's in that absolute value equation form. And we have the blue equation right there, f of x. We have the graph g of x equals 5. Do these intersect? Yes, they intersect right there. They intersect at 1. So this is what an absolute value equation looks like graphically if there's only one solution. It's like the vertex of the absolute value equation is touching the other value at just one point. And I didn't say that, I think, very well at all, but you can see what this looks like, absolute value equations look like if there's one solution graphically. So what about algebraically? This is going to be more efficient. It'll be neater. It'll be more precise, because with graphs, you know, sometimes those things get a little messy and take a lot longer to write those things out. But algebraically is pretty nice here. So to solve algebraically, we're going to isolate the absolute value expression and then decide whether the equation can be solved. Keeping in mind that an absolute value, it can't be negative. That's why. And then we're going to write as two separate equations. So what that looks like, and write as two separate equations. Saying that out loud right now might be confusing, but once we get there, it should become pretty clear why it says this. So we have negative 2 times the absolute value of 3x minus 4 plus 8, and this equals 4. So the first thing we want to do is isolate this absolute value portion of this equation here, and then we can move forward with whatever scenario we have. So the first thing I'm going to do, which is like solving an equation, I'm going to subtract 8 on both sides first. So I subtract 8 on both sides. Now this plus 8 is gone, and then if I subtract 8 over here, 4 minus 8 is negative 4. Absolute value portion is not by itself yet, so we're going to divide by negative 2. So divide both sides by negative 2, and negative 4 divided by negative 2 is a positive 2. And now we have the absolute value portion here by itself, and this equals 2. So what this means now is, what number does 3x minus 4 need to be equal to, such that whatever it's equal to, its absolute value is 2? Well, there are two things that can go inside here. There are two numbers. 3x minus 4 could be positive 2, because the absolute value of positive 2 is 2, or 3x minus 4 could be negative 2, because the absolute value of negative 2 is also 2. So this is where this two separate equations comes into play here. We have 3x minus 4, that could be equal to 2. Or 3x minus 4 could be equal to negative 2, because both of these values here have an absolute value that is equal to 2. And now we have very basic algebra, and we're just going to solve both of these equations. Over here, add 4 to both sides, and you get 3x equals 6. Add 4 to this one, kind of doing both of these at the same time. Add 4 to both sides here, and 3x equals 2. Back over to this one, solve for x, divide both sides by 3, x is 2. Over here, divide by 3, or x could be 2/3. So the solution to this equation here, this x could be 2, or this x could be 2/3, because if you plug in 2, then this whole side will be equal to 2, absolute value. It works. If we plug in 2/3, well, it'll be -2. That also has an absolute value of 2, and we'll end up with 4. So that's how we solve it algebraically. A little bit more neater than graphing. Let's try one more. Absolute value of 5 plus x plus 7 equals 1. Subtract 7 on both sides. You get 5. The absolute value of 5 plus x is equal to -6. Well, we have to ask ourselves, 5 plus what? What has an absolute value of -6? What can I put in here so that the absolute value is -6? Well, that's nothing. So there's no solution because an absolute value cannot be negative. We can put a negative in here, but whatever comes out will always be positive. So this equation, and subsequently this equation, has no solution at all because the absolute value has to be a positive number. So no solution. Another one, 2 times the absolute value of x minus 1 plus 5 equals 9. Isolate the absolute value, subtract 5 on both sides, so you get 2 times the absolute value of x minus 1 equals 4. Now we're going to divide by 2. So the absolute value of x minus 1 is equal to 2. So what does x minus 1 need to be? What numbers need to go in here so that their absolute value is 2? Well, much like we saw before, it's got to be either 2 or -2. That's what x minus 1 has to be equal to. So what does the x need to be to make that happen? Well, add 1 to this side, add 1 to this side over here, same deal. X could be 3, or x could be -1. So the solution to this equation is 3 or -1. Both of those will work and give us something that is equal to 9. If we solve that graphically, this is exactly what that would look like. So here's that y equals 9. Here's the y equals 2 times the absolute value of x minus 1 plus 5, and they intersect at -1 and +3, which is exactly what we have here. Another one. All the information here, so hopefully you can keep up, I hope. So, but it's all here, and all the algebra's there, and then the graph is there too. So, -2 times the absolute value of x plus 5 plus 4, again, add or subtract 4 on both sides is what's happening here. -2 times the absolute value of x plus 5 is equal to -2. Divide both sides by -2, and we get x plus absolute value of x plus 5 is equal to 1. So that means that x plus 5 could be 1, or x plus 5 could be -1. Subtract 5 on both sides, and we get x is -4 and x is -6. It could be either one of those values. And here's what this looks like graphically there. Very similar to that last example we did. This one, no solution. 1/4 times the absolute value of x plus 2 plus 7 equals 5. Again, subtract 7 on both sides. We're trying to isolate the absolute value. Multiply both sides by 4, so you have absolute value of x plus 2 equals 8. This is no solution. So what does that look like graphically? It looks like this. So there's no solution, much like when we've seen systems of equations in the past. There's no solutions if the two lines don't intersect. And here, the two graphs don't intersect because we have we have 5 right here. So there's 5. And then we have the 1/4 times the absolute value of x plus 2 plus 7 right here. There's no solution because there's no intersection. And that is how you solve absolute value equations with graphs and algebraically.